Today we are looking at lesson 7.5, scale drawings. Our I can statements: I can use scale drawings to find actual distances. I can find scale factors. I can use scale drawings to find actual perimeters and areas. And I can recreate scale drawings at a different scale. All right, so for our key idea here, scale drawings, proportional, two-dimensional drawing of an object. That's like something like a blueprint, which is a drawing of a building or something else being constructed, or a map. A scale model is a proportional three-dimensional model of an object. A lot of times scales are smaller than what the actual thing is, but sometimes it happens to be larger. When you write scale, you're going to write it like a ratio. So on this first one here, we have 1 inch to 10 miles. Scale has two different units, and the scale always goes first. So you can write it like this with a fraction bar, or you can write it with a colon. Either way is fine. All right, so let's take a look at our first problem here. It says, what is the actual distance D between Cadillac and Detroit? And I have a point here on both of those cities, and I took a ruler and I lined it up. Now, if you look at our map here, our scale for our map is 1 centimeter corresponds to 50 miles. So I'm going to write 1 centimeter over 50 miles. Okay, and then I'm going to look at what my measurement was. So it looks like maybe 5, it almost looks like 4 lines here. So I'll call that 5 4/10 centimeters. And we want to know how many miles that means. Scale goes on the top, actual goes on the bottom. We know the scale, we want to know the actual. All right, so let's see, I'll do cross products. 1 times x is just x. And then I need to do 5.4 and multiply times 50. So let's see. 5.4 times 50 gives us 270 miles. All right, number 1, what is the actual distance between Traverse City and Marquette? So we have the same scale. We need to find our two things here. So Marquette is up here and Traverse City is right here. We're not going to figure out how long it would take to drive, because you have to drive around the lake. But we just want to know the actual distance. So you're going to try this one on your own, but since you can't really measure off of your computer screen very well, I'm going to go ahead and line up the ruler for you, and then I will have you pause your video and calculate. But I'm going to get the rulers lined up as a start for you, since you can't really measure on your own screen. Okay, we're going to call that 5 centimeters. So go ahead and calculate the actual distance between Traverse City and Marquette. Pause the video, try it on your own. All right, so let's see. We've got 1 centimeter for 50 miles. And then we said that this was about 5 centimeters. We want to know how many miles. All right, let's see. Over here, I see a multiplication pattern times 5. So I can do that same pattern here, times 5, and I'm going to get 250 miles. All right, let's look at our next type of problem. The liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? So we're going to write and solve a proportion. Again, for these types of problems, we're going to do scale over actual. Here's the scale information, 1 inch to 500 kilometers. And then on the other side of the proportion, you have to make sure you're lining up your labels the same way. So inches would still go on top. Kilometers would go on the bottom, and then the information they give us is in kilometers, so that number has to go on the bottom, 2,300. All right, so let's see. I'm going to do cross products on this one. 500 times x is 500x. 1 times 2,300 is 2,300. Then I'm going to divide both sides by 500. You can use a calculator, that's fine. But you do need to make sure that you're writing down your work as you go. So 500 divided by 500 is going to be 1, which is why I'm left with just 1x. And then I'm going to do 2,300 divided by 500, and I'm going to get 4.6. Label here next to my x was inches, so 4 6/10 inches. Yes, you do need to have all of that work written down. All right, number 2, the mantle of Earth is 2,900 kilometers. So how thick is the mantle of the model? All right, go ahead and pause the video. Try this one on your own. Okay, let's check our answers. So going back to this last one, we have the same scale, 1 inch to 500 kilometers. This time our number for our actual is 2,900. That's my kilometers number. We're looking for a number of inches. When I do cross products, I get 500x equals 2,900. And we're going to divide on both sides of our equation by 500. All right, and let's see, 2,900 divided by 500, 5.8. So 5 8/10 inches. Your work should look very, very close to mine. All right, let's take a look at this next one. A scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model and what is the scale factor? Okay, so just as a reminder, for scale, we have 2 units. And we need to make sure that we write it in simplest form. All right, we always do scale and then actual. So scale here was 10 inches. And you can use a fraction bar, or you can use a colon. A lot of times you see a colon for scale. Either is fine. Okay, 10 inches to 100 feet. Just like any other ratio, I want to make sure I make it in simplest form. So I'm looking for common factors that I can divide by. Here I can divide by 10 and 10. So my simplest form of the scale is going to be 1 inch to 10 feet. That is scale. 2 different units, simplest form. However, for B, it says scale factor, and scale factor is a little bit different. It tells how many times bigger. So to do this, we need to make them the same unit. So we have to convert it to be the same unit, and then we make the smaller number equal 1. Smaller number equals 1. And on this one, then on our answer, we have no units, no labels on our answer because it tells us how many times bigger. That's what scale factor means. Okay, so I'm going to go back 10 inches to 100 feet. This time I'm going to write it as a fraction just because a lot of times you see scale factor as a fraction, but that doesn't matter. I could have written it with a colon like that if I wanted to. Okay, so I need to make them the same unit. So I'm going to change my feet into inches so I don't have to deal with decimals. So to do that, I'm going to multiply by 12 since there are 12 feet in, 12 inches in a foot. So I have 10 inches over 1,200 inches. So I took 100 times 12 to get 1,200. Those labels are going to cancel out. So now it's like 10 over 1,200. My smaller number needs to equal 1. So to do that, I'm dividing both the top and bottom by my smaller number. A lot of times it will give you a whole number, but sometimes you see a decimal. 1200 divided by 10 is going to give me 120. So what is my scale factor? 1 over 120, 1/120th. All right, a drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor of the drawing? You're going to try this one on your own. However, I'm just going to let you know, in case you're not sure, that there are 10 millimeters in 1 centimeter. So when you're converting the centimeter, you're going to have to take it times 10 to get it to be in millimeters. All right, go ahead and pause the video and try this on your own. All right, let's check our work. So 1 millimeter to 20 centimeters. And I said you're going to have to multiply that 20 centimeters times 10 to get it to be millimeters. So 1 millimeter over 200 millimeters. Labels cancel out. My smaller number happens to already be 1. So my scale factor is 1 over 200. That means the actual is 200 times bigger. All right, so let's take a look at this next one. It says the scale drawing of a computer chip helps you see the individual components on the chip. Part A says find the perimeter and area of the computer chip in the scale drawing. All right, so they tell us the picture here. 1 centimeter corresponds with 2 millimeters. This is an example of a scale drawing where the scale is actually bigger than the actual. The actual computer chip is so teeny tiny, the scale makes it a little bit bigger so that you can actually see it. So the first thing we need to do is to get out our ruler and measure in centimeters on the picture so that we can figure out what the perimeter and the area is. So I'm going to line up my ruler here on the edge. This is a square, so all of the sides are going to be the same. I'm just going to measure the bottom here. Looks like 0 going to 7 point. It's a little hard to tell. Looks like maybe 7.7. Okay, so I'm going to call this side 7.7 centimeters, and it's always a good idea to double check that they're the same. Oh, pretty sure this is a square though. Let's see. Yep, 7.7. Okay, so I'm going to get the ruler put away, and I'm ready to do my math. Okay, so perimeter means you are adding the sides together. So we're doing the scale drawing first. Okay, so for perimeter, each side is 7 7/10 centimeters, and there are 4 of those sides. So I can take 7 7/10 and I can multiply times 4 to get my perimeter. I could also add it 4 times, but I don't feel like writing that out 4 times. Okay, so I get 30.8 centimeters. Okay, now I'm going to do the area. Area for a square is length times width. So I'm going to do 7.7 times 7.7. So length times width. And it is okay to use a calculator, but again, you've got to write everything that goes into that calculator down. Okay, so that is going to be centimeters square. Area is always in square units because you are multiplying length that has a label of centimeters and width that has a label of centimeters. Okay, so that's my perimeter and area for the computer chip picture here. Now I need to find the actual perimeter and the actual area of the computer chip. So in order to figure that out, I need to use my scale to find out what the actual millimeter measurement is going to be. So I'm going to do my scale over actual 1 centimeter to 2 millimeters. And then we know in the picture it was 7.7 centimeters, but we don't know what that matches up with for the actual yet. Okay, so let's see. I'm noticing here, top to bottom, I'm timesing by 2. The label's changing, but the number is multiplying by 2. So I'm going to do the same thing here. I'm going to do 7 and 7/10. I'm going to multiply by 2. And I'm going to get x equals 15.4 millimeters. Okay, that means that the actual computer chip would have a side length of 15 4/10 millimeters. Okay, so now I'm going to go ahead and do the same thing I did above, but instead of using the number 7 and 7/10, I'm going to use the number 15 4/10. So I'm still doing these same exact things for perimeter and area. It's just I have a new number to do it with, and I had to get my number from using my proportion. All right, so 15.4 times 4, because it's a square, we're adding all of those sides together. That's going to give me 61.6. And then let's see, that's millimeters. Don't forget your labels here for area and perimeter. Really important that we've got those labels. For area, we're doing length times width, so 15.4 times 15.4. And let's see what we get for that. 237.16 millimeters squared. Area is always in square units. Okay. Then for part C, they want us to compare, just to look at the pattern for how perimeter changes and area changes within a scale. So compare the ratios, drawing perimeter and actual perimeter, and drawing area and actual area to our scale factor. Okay, so first thing I need to do is figure out the scale factor for my information here. Okay, 1 centimeter to 2 millimeters. 1 centimeter, this was my scale, to 2 millimeters, but if I need to make it scale factor, that means my units have to be the same. So I'm going to change my centimeters to millimeters by multiplying by 10. So that would give me 10 millimeters over 2 millimeters. My labels cancel out. When I do 10 divided by 2, I get 5, or 5 over 1. Is our scale factor. What that means is the scale is 5 times bigger than the actual thing. Okay, so now I'm going to look at these ratios and I'm going to compare them to my scale factor of 5. So for my perimeter, looks like here I had 61.6. And above I had 30.8. Okay, oh, I almost forgot about my labels. Labels are important here. This was millimeters. And on the top, that was centimeters. Okay, so they want us to compare it to scale factor, which means I need to do the same steps I did with scale factor, make them the labels the same, and then see how my numbers end up comparing to our scale factor. So I'm going to take my centimeters, I'm going to multiply them by 10 to make them millimeters. So that would be, what, 308 millimeters for 61.6 millimeters. Let's see how that divides out if I want to take my numerator and divide by my denominator to compare. And I get 5, exactly 5 over 1. Okay, so that is the same as the scale factor. Okay, now I'm going to do the same thing, but with the areas. Okay. So my area on the top, 59.29. Okay, did I get that right? Yeah, 59 and 29 centimeters squared. All right, and then my area on the other one was 237 and 16 millimeters squared. Here I have 2 centimeters. So to cancel it out and make it millimeters squared, I actually multiply by 10 twice. Times 10 for the first centimeter, times 10 for the second one. So that actually is going to give me 5,929 divided by 237.16. So that gives me the same units, millimeters squared on the top and millimeters squared on the bottom. And when I divide them, let me just double check. 59.29 divided by 237 and 16 hundredths. Yes, I get 25. Which is the scale factor squared. 5 squared equals 25. And that's because we had to multiply 2 times to convert here. We've got centimeters squared. Your number is getting multiplied twice. So our scale factor ends up getting multiplied twice, scale factor squared. All right. Number 4, what if the scale of the drawing of the computer chip is 1 centimeter to 3 millimeters? How do the answers in parts A through C change justify your answer? All right, so you're going to try this on your own. You do not have to calculate it all out. You certainly can. But you can also just say for each one, how does it change? Does it stay the same? Is it going to get bigger? Is it going to get smaller? So go ahead, pause the video, and write down what you think for this one. Okay, let's check our answers. So for part A, perimeter and area of the computer chip in the scale drawing. The scale here is now, instead of 1 to 2, it is now 1 to 3. Okay, so for part A, does our picture change the same? Yeah, it doesn't change. There's no change. Picture is still the same size. Okay, part B. 3 millimeters here. 2 millimeters here. All right, so when we find the actual perimeter and the area of the computer chip, and instead of multiplying by 2, we're going to multiply by 3. So our actual perimeter and area will be a little bigger. Actual perimeter and area will be bigger. This is justify, so let's explain it a little bit. Because you multiply by 3 instead of 2. On this problem, we multiplied by 2 to get our new number. Now we would multiply by 3. So that would make it a little bit bigger for the actual. And then for part C was the ratios, and the ratios would be the same. The perimeter will have the same perimeters ratio, same as scale factor. I'm just going to abbreviate SF. Areas ratio is scale factor squared. Okay, last one to try here. Common model train scale is called the HO scale, where the scale factor is 1 to 87. Notice that's scale factor and not scale. There are no labels in that with that number. If the diameter of a wheel on a model train is 3/10 inch, what is the diameter of the actual wheel? All right, go ahead and pause the video and try this one on your own. Okay, let's go ahead and try it. So we've got 1 over 87 for our scale factor. That means that the actual is 87 times bigger than the model. The model here was 3/10 of an inch, and we are looking for what the actual is going to be. Scale factor does not have labels, so that means our labels over here are going to stay the same, inches. Okay, 1 times x is just x, and then I need to do 87 times 3/10. So let's see, 87 times 3/10 gives me 26 and 1/10 inch.